Hi and Assalamualaikum everyone. I am student of A4 AS12015. Today me and my friend from group 3 would like to present to you about experiment of Newton's second law of motions. But first, let me introduce myself first.
My name is AMIRA NADIEA binti Ahmad HUSSAIN with ID number 2021-473746.
Assalamualaikum warahmatullahi wabarakatuh. My name is ADRIANA binti MOHAMAD HAIRRY. My ID student number is 2021-615848.
Hello and Assalamualaikum. My name is NABILAH binti SHAH and my ID number is 2021-816224.
Assalamualaikum and hi everyone. My name is HANISHA binti HAIRUDDIN and my student ID is 2021-449082.
The objective of the experiment is first, investigate the relationship between the total force acted on object with the acceleration of the object. Second is to study the Newton's second law of motions. We use this PET simulations link to carry on our experiment.
In this video, I will explain about the procedure of Newton's law of motion experiment. Student will be given two conditions, which is part A, non-friction, part B, for friction. So the procedure for part A, which is non-friction, is first, the link provided was clicked. Second, the play button was clicked. Then proceed to choose the force graph tab. Then the screen will appear. The parameter was adjusted. First, small crate was being chosen as an object. Second, ice was being chosen at the friction section for the experiment condition, which is no friction. Then lastly, acceleration graph was added by click on the acceleration graph as shown. Then, before the experiment begins, the force was adjusted. The force will apply to 500 Newton. Then, the play button was clicked. At the end of the experiment, reset all button was clicked for second reading. Above step was repeated at least 3 times for each data to get more accurate data. Then lastly, step 4 until 9 was repeated to get another 9 data, which is the force applied to 600, 700, 800, 900, 1000, 1100, 1200, 1300 and 1400 Newton. Next, the procedure for experiment part B, which is friction surface. The procedure for this experiment is same as experiment part A, but the difference here is experiment part B use wood as the condition of experiment, which has friction surface. So the procedure for this experiment is first, the force graph was clicked. Then the parameter was adjusted. Firstly, small crate was chosen as an object. Second, wood was being chosen at the friction section for the condition of experiment, which has friction. Lastly, acceleration graph was added by click on the acceleration symbol as shown. We will begin with experiment by adjust the force. The force applied to 500 Newton and the play button was clicked. After that, the acceleration was being recorded in the table of data 2. At the end of the experiment, reset all button was clicked for the second reading. Above step was repeated at least 3 times to get more accurate data. Lastly, step 4 until routine 9 was repeated for another 9 data.
So here is the result after we carry out the experiments. For the result of non-friction surface, as you can see here in the table, the friction force is 0. So the applied force is equal to the total force. We start this experiment with 500 Newton and we increase it by 100 for each data, and we do it for 9 different applied force. So for the 500 Newton, as you can see, the result for the acceleration we got here is 5.00. We repeat it for 3 times, so we got 4 data here for each applied force. For the friction surface, the friction force is negative 294 as stated in the simulations. The friction force for each data is same because we use the same surface, which is wood. So the total force is equal to the applied force plus the friction force. So the total force for the 500 Newton is equal to 500 Newton plus negative 294 equal to 206. And here also we repeat the experiment for 3 times more, so we got total of 4 data for each applied force.
So for my part, I will presenting about the graph and the analysis. Okay, the first question here is for the data plot graph for graph A, total force as a function of acceleration for non-friction surface. So as we can see here, the y-axis for this graph is the total force, while for the x-axis is the acceleration. So we can see that the graph is the linear, or we can say that the total force is directly proportional to the acceleration. So I also put the coordinate here like 5 and 500, and also 14 and 1400 to easier count for the gradient. Graph B is the total force as a function of acceleration for friction surface. So as we can see here, the y-axis is still same, which is the total force, and the x-axis is also the same, which is the acceleration. And this graph is also linear, or we can say that the total force is directly proportional to the acceleration. And I also do the same thing. I put the coordinate for easier to us to calculate the gradient. So for the next question, it say that find the value of gradient slope of the graph. So we must use the gradient formula to find the gradient itself. So the formula is y2 minus y1 divided by x2 minus x1. So to find the gradient, we should have 2 coordinates. So for the graph A, the first coordinate is the 5 and 500, while the second coordinate is the 14 and 1400. So we put the value into the formula and we calculate it, and the result is 100 for the gradient for the graph A. So next, for the graph B, we use the same formula, and the coordinate for the first coordinate is the 2.06 and 206, while the second coordinate is the 11.06 and also 1106. So we put the value into the formula and we calculate it until the end, and we got the 100 gradient for the graph B. So both graph have the same gradient, which is 100. So for the next question is the third question. Find the coefficient of kinetic friction mu k between the small crate and and the wood surface from this simulation. So as it's mentioned here, between the small crate and the wood surface, the wood surface will be highlighted here. So the value I will use after this is based on the friction surface data. So as we can see here, wood surface equal to the friction surface. The formula here is the F equal to the MA. Why? Because as I say at the beginning, F directly proportional to the A, to the acceleration. So F is a force, M is the mass of the small crate, and A is stand for the acceleration. If we expand this formula, it will be F equal to the FA minus FK. FA is stand for the force applied, while the FK is the friction force, and it can label as Fx also. So we can see here at the bottom, I write is FA minus Fx equal to MA, right? So Fx is, we can find Fx is the mu k multiplied with n. So n is what? N equal to F. So F is the normal force. The formula is the F equal to mg, which means that m is mass and g is the acceleration of the gravity. So continue to the calculation here. So Fa force apply is the 500 Newton minus mu k multiplied with mg. So m here, mass here is the 100. How can we find the 100? It's come in the simulation itself. And the g is the acceleration of the gravity. So as we know, the acceleration of gravity is 9.81. So we put in here, and equal to mass. Mass is 100, as I say at the beginning, and multiply with 2.06. So 2.06 is the value from the friction surface data. So we calculate it, and we get the mu k is the 0.3. So the coefficient of kinetic friction is 0.3. Okay, for the last question is the fourth question. Using Newton's second law of motion, calculate the coefficient for kinetic friction mu k between the small crate and the wood surface. Compare the calculated value with the value obtained from this experiment. So I will highlight the compare the calculated value with the value obtained. So we can get the obtained value from the simulation itself, and it shows that the mu k is the 0.3. Well, the value that we calculate for the mu k, we also get 0.3. So we can conclude here that both of the value for the obtained value and calculate value is same, which is have the coefficient for the kinetic friction is the 0.3.
For the discussion part, I'm going to discuss based on the question given. The first question is from the plotted graphs, discuss the relationship between the total force with the acceleration of the object. As we know, acceleration is directly proportional to force and inversely proportional to mass. From the graphs, we can see that the acceleration increase when the force increase. So the relationship between the total force and the acceleration of the object is the greater the total force applied on an object with a given mass, the greater the acceleration of the object. Next, we go to the second question. Relate the trend of the graphs with Newton's second law of motion. The trend of the plotted graphs are that both of the graphs accelerating against the total force in a straight line. The Newton's second law of motion stated that force is equal to mass times acceleration, but in a constant mass. Obviously, the trend in both graphs are obeying the Newton's second law of motion. For the third question, discuss the value of the gradients obtained from the graphs. The value of the gradients obtained from the graphs are same, which is 100 Newton per meter second square. Actually, the gradient in both graphs represent the weight of the small crate. The gradients were obtained from two coordinates in each graph, which is for the non-friction graph, the first coordinate is 5 and 500, while the second coordinate is 14 and 1400. For the friction graph, the first coordinate is 2.06 and 206, while the second coordinate is 11.06 and 1106. After that, these coordinates were inserted into the gradient formula. The fourth question is state and discuss the physical quantity represented by the gradient of the graph. The physical quantity represented by the gradient of the graphs is mass, and the SI unit for it is kilogram. The y-axis in both graphs represent the total force applied, and the y-axis in both graphs represent the acceleration of the object. So, from the formula, which is F equal to ma, the mass can be obtained by using m equals to F over a. So, question number 5. Explain any experimental errors that may occur in this experiment if this experiment is done in real life. The experimental error that may occur if this experiment is done in real life is random errors. Random errors can be possibly happen from the readability of the instrument or the effect of changing in surroundings between the measurement or from the observer itself. But in this experiment, the random error is highlighted to the observer itself, which is the observer being less perfect in handling the experiment. If the small crate was pushed by a person, the amount of the total force might not be able to measure accurately. So the last question for the discussion part is give suggestion or precaution for improvement of this experiment if this experiment is done in real life. The improvement that could be done is by repeating the experiment itself for at least 3 times to get the accurate result as possible. Besides, using a high quality of laboratory equipment might help because most of the high quality equipment can lead to low percentage of uncertainty, which means the result obtained can be close to accuracy. So that's all for the discussion part.
In conclusion, as stated in the Newton's second law of motions, the force acting on an object is equal to the mass of the object times its accelerations. Hence, the acceleration of an object as produced by the net force is directly proportional to the magnitude of the net force and inversely proportional to the mass of the object. So that's all from us, Group 3. Thank you and see you again.